Good morning, everyone. This is M. Pawan from IRE College, Data Science Branch, B section. Now I am here to explain one concept in probability and statistics, probability density function. In shortcut, we can call it as PDF. Today, in our session, we will learn what is the theoretical part of this probability density function and how we solve the problems and the formula of it. Okay, we will move on to next slides. Introduction. Probability density function is a function that provides the likelihood that the value of a random variable will fall between a certain range of values. We use the probability density function in the case of continuous random variables or discrete random variables. We use the probability mass function, which is analogous to the probability density function. Means probability density function that provides the livelihood that the value of a random variable that falls a certain range of values. So for discrete random variables, we use the probability mass function, which is analogous to the probability density function. The graph of the probability density function is in the form of a bell curve. The area that lies between two specified values gives the probability of the output of the designated observation. We solve the integral of these in function to determine the probabilities associated with a continuous random variable. In this article, we will do a detailed analysis of the probability density function and take a look at the various aspects related to it. Okay. What is probability density function? Probability density function and cumulative distribution function are used to define the distribution of continuous random variables. If we differentiate the cumulative distribution function of a continuous random variable, it results in the probability density function. Conversely, on integrating the probability density function, we get the cumulative distribution function. Definition. Probability density function defines the density of the probability that a continuous random variable will lie within a particular range of values. To determine its probability, we integrate the probability density function between two specified points. Example, say we have a continuous random variable whose probability density function is given by f of x is equal to x plus 2 when 0 less than x less than or equal to 2. We want to find p of 0.5 less than x less than 1. Then we integrate x plus 2 within the limits 0.5 and 1. This gives us 1.375. Thus, the probability that the continuous random variable lies between 0.5 and 1 is 1.375. This is the example of our PDF. Formula. The probability density function of a continuous random variable is analogous to the probability mass distribution of a discrete random variable. Discrete random variables can be evaluated at a particular point, while well, continuous random variables have to be evaluated between a certain interval. This is because the probability that a continuous random variable will take an exact value is zero. Given below are the various probability density function formulas. Okay, probability density function of continuous random variable. Suppose we have a continuous random variable x. Let f of x be the cumulative distribution function of x. Then the formula for the probability density function f of x is given as follows. F of x is equal to df of x by df of x by dx is equal to f dash x. This is the formula of f of x, which is probability density function. If we want to find the probability, if we want to find the probability that lies between lower limit a and upper limit b, then using the probability density function, this can be given as p of a less than x less than or equal to b, that is equal to p of b f of b minus f of a to the a to b. It implies integral f of x dx. Here f of b and f of a represent the cumulative distribution function, cumulative distribution function at b and a respectively. So we can going to give these things. Probability density function of normal distribution. Normal distribution is the most widely used type of continuous probability distribution. The notation for normal distribution is given as x implies n of mu comma sigma 2 into x. The probability density function of a normal distribution is given below. F of x is equal to 1 by sigma square root of 2 pi e power minus 1 by 2 x minus mu divided by sigma whole square, where mu is the mean, sigma is the standard deviation, and sorry for that, sigma square is the variance. Probability density function graph. If x is a continuous random variable, then the probability distribution of this variable is given by the probability density function. The graph given below despises the probability that x will lie between 2 points A and B. Graph of probability density function. Here, the A and B are in both x-axis and the positive side of the x. So the graph is like a dumbbell. From P of A less than or equal to x, x less than or equal to b, in between f of x and x to the origin O. This can be our graph. Okay. Next. Mean of probability density function. In the case of a probability density function, the mean is the expected value or the average value of the random variable. If f of x is the probability density function of the random variable x, then mean is given by the formula E of x is equal to mu is equal to integral minus infinity to infinity x into f of x dx. This is the formula for the mean of probability density function. Median of probability density function. The median is the value that splits the probability density function into two equal halves. Suppose x is equal to m is the value of the median. The area under the curve from minus infinity to infinity to m will be equal to the area under the curve from m to infinity. This implies that the value of the median is 1 by 2. This means from minus infinity to m will be the one part and m to infinity will be the other part, which is equal in area. This implies median is 1 by 2. Thus, the median of the probability density function is given by as follows: integral minus infinity to m f of x dx is equal to m to infinity f of x dx is equal to 1 by 2. This is the median formula of probability density function. Median of probability density function. In this graph, we can observe that the graph is in parabola. Sorry, the graph is in bell shape or parabola, but the area, see the area is equal to from minus infinity to m, area is equal to 1 by 2. From m to x, it is area my 1 by 2. Say it means since the area of both the parts are same. This is what we call as median of probability density function. We can observe that from here. Variance of probability density function. The expected value of the squared deviation from the mean is the variance of a random variable. Expressing this definition mathematically, we get variance of x is equal to E of capital X minus mu into 2. To represent this variance with the help of the probability density function, the formula is given by variance of x is equal to mu square is equal to minus infinity to infinity x minus mu whole square f of x dx. Means variance of probability density function is defined as the expected value of the squared deviation from the mean is the variance of a random variable. Expressing its definition mathematically, we get variance of x is equal to E of capital X minus mu into 2. To represent this variance with the help of the probability density function, the formula is given by variance of x is equal to mu square is equal to minus infinity to infinity x minus mu whole square f of x dx. Properties of probability density function. the properties of the probability density function. Density function helps to solve questions faster. If f of x is the probability distribution of a continuous random variable x, then some of the useful properties are listed below. So the properties of helps the properties of PDF helps to solve questions faster. If f of x is the probability distribution of a continuous random variable x, then some of the useful properties are listed below. If f of x greater than or equals to 0, this implies that the probability density function for all real numbers can be either equal to or greater than 0, but it can never be negative or less than 0. Then you can find that if the PDF f of x if greater than or equal to 0, that implies PDF for all real numbers can either be equal or greater than 0, but not less than or negative. Less than 0 or negative. If integral minus infinity to infinity f of x dx is equal to 1, then the total area under the probability density curve will be equal to 1. Okay, I hope everyone understand these properties, formula and example of PDF probability density function. I hope everyone gets some idea on what is probability density function. Thank you for giving me this wonderful opportunity to explain you this concept. I hope everyone enjoyed my session. Thank you all.